Hello and welcome everybody to my new video. This will be part of my modeling nature playlist. In this playlist, most of the time I'm talking about general modeling approaches. So how to proceed when you want to model a snail shell, for example, as in my last video. This time, however, I want to show you the Pov-Ray scripting language in more detail. In case you perfectly understand the other videos and in case you are not interested in Pov-Ray, this won't be of much interest to you. On the other hand, in case you are not sure what I mean by positions, vectors, and so on, or in case you really might want to give Pov-Ray a try, this is the video for you. In the background, you see the picture I want to model together with you today. This is only a little exercise without much meaning. Take it, for example, as a spaceship attacking another spaceship using a laser. Anyway, it only serves me for showing you some of the interesting tools in Pov-Ray. If you install and start Pov-Ray, you will see a screen like this. Now we best start with an empty pre-made scene. So we select Insert from the menu and then Ready-made Scenes and Basic Scene 11. This script will be loaded and we can take a look by pressing the Render button. You can see the rendered image in a separate window. You can see there are several cameras defined, with camera 0 being the active camera, one light source and a white sky sphere. Now we want to remove the letters in the background. We have to scroll down to find it. So this text object contains these words pure white background. We simply delete it and replace it with my standard coordinate system composed of 3 cylinders. This system helps me orientate myself in the rendered images. Let's have a look at the first cylinder to learn a bit about the scripting language. Within the cylinder object, first there is the definition of the starting and the end point of the cylinder. Both points are given as x, y, and z coordinates in the form of vectors. This notation is the usual approach in Pov-Ray to indicate vectors, and we will see it very often. Then comes the radius of the cylinder, 0.02, and the pigment definition. And the color of this pigment, again, is given as a vector, using red, green, and blue as the main axis in color space. Okay, for your orientation, I'm always using a red x-axis, a green y-axis, and a blue z-axis. Now let's start scripting by inserting a sphere from the Insert menu. If you look at the script, the sphere is first initiated at the origin and has a radius of 0.5. Then comes the simple texture with the pigment definition and the finish, which makes the sphere somewhat shiny. And finally, the translate statement is used to move the sphere by 0.5 up the y-axis. Now let's take a step back and move the camera a bit so we have a larger field of view. And move our sphere somewhat more. As you can see in the script, we move it by 4 along the x-axis and then rotate it by minus 40 degrees around the y-axis. It is time to show you a first loop. Here it comes. Have a look at the syntax. We defined a variable ticker and set it to 0. Then we said our loop should continue until ticker reaches 12. Inside the loop, we defined our sphere, which is rotated by minus 30 degrees multiplied by ticker. And before the loop's ends, we increase ticker by 1. This results in precisely 12 loops, with the sphere being rotated multiples of 30 degrees, as you see in the render window. For complex models, I prefer to define and store my positions at the beginning of a script and then use these stored positions in a later part. Here I'm showing you how this works. On top of the scripts, we are defining an array named positions with 12 elements. Then we use a loop to define our positions P1 and to store them in the array. You have to note that arrays in Pov-Ray always start with element number 0. In the second part of the script, we use another loop to read our positions from the array as a point P array and to place a sphere on this point. This may seem somewhat complicated, but it facilitates things when working with more complex structures. Now let's have a look at random numbers, which I am using very often. For this, I am now using 100 rather than 12 positions. In Pov-Ray, the rand function always produces a number between 0 and 1. Here I have initiated such numbers at the top of the script. Then I use them for defining positions in the first loop. We define these positions by first selecting a random position between 2 and 5 on the x-axis, and then by making a random rotation by an angle between 0 and 360 degrees around the y-axis. Here comes the same thing with a wider radius between 2 and 7 on the x-axis and 1000 elements. I want to shortly summarize this first part of the video. It gives a good example for what I always found fascinating about Pov-Ray. You can specify pretty complex looking structures by a few simple lines of code. You only need a simple loop and a few random numbers and you arrive at something resembling the rings from Saturn. Now, just to make this clear from the very start, there are other things which are very hard to model in Pov-Ray, the human body for example. So in case you want to model pirates or princesses, you should look for some other programs. In the second part of the video, I want to show you a few things you can do with vector in Pov-Ray. You can do, of course, the usual stuff of vector mathematics, addition, subtraction, dot and cross product, but there are also some more sophisticated functions. Okay, now let's assume this is something like Saturn's wings, and this here is a little schematic purple spaceship just below the wings. I want to show that this spaceship can affect the elements of the wings, and for this I'm using the inside function from Pov-Ray. First, I'm defining a second object, double the size of the first one, using scale, spaceship env. Then I'm including an if statement in my loop for the wing elements. Inside will give you 1 when a certain vector is inside a given object and 0 when it is outside. My if statement says that whenever the position of the element is inside spaceship env, inside is larger than 0, the element should have a blue color, otherwise the standard orange color. As you can see in the rendered image, the elements close to our spaceships are really blue by now. Let's move our camera a little closer to have a better look. I want to demonstrate you one last vector function from Pov-Ray, and for this we need another spaceship. Here it comes. I've called it attack. Now we insert a ray of laser light, a cylinder between the two spaceships. The function I want to demonstrate here is trace. This allows you to obtain the position where a given vector touches a given object. In this example, we are looking for the position where the ray of the laser light touches our first spaceship. This position is stored in the variable impact. Here I have used a yellow sphere to show this position. Here I will leave it like this. I still played around a bit with script, changing camera position, textures, defining the ring elements as meter balls, installing an additional light at the side of the impact to reach a picture as you see in the background. But this video would become too long when going through all these changes. Anyway, it will be interesting for me to see how this video will perform compared to the other more general modeling videos. Comments regarding your preferred level of detail are always welcome.